calibrate the NC3 or NC4, we will need a tool with a known length and diameter. We will use a pin in the tool holder, sticking out about 15 millimeters from the face of the collet. Using a dial indicator on a mag base, position the dial indicator right underneath the spindle. In handle jog mode, move the Z-axis of the CNC in the negative direction until the face of the spindle touches the indicator. In 1 micron increments, continue moving the Z-axis in the negative direction until the needle on the indicator lines up with the 0. While still in handle jog mode, we're going to set our current Z position as our reference. We're going to press the position key, and this will be followed by pressing the Z alphabet key, and then we'll press the origin key. This sequence of steps should set the Z operator position to 0. Without touching the dial indicator and the mag base, hand jog the Z-axis in the positive Z direction, and then load the calibration tool into the spindle. In handle jog mode, move the CNC axis in X, Y, and Z until the end of the tool is touching the indicator. In 1 micron increments, move the Z-axis until the needle on the indicator lines up with the 0. The indicator needle should move the same number of revolutions as it did when it touched the base of the spindle. The operator position is going to be the length of your calibration tool. Input this value into the tool length offset corresponding to the tool in the spindle, and also input the diameter of your calibration tool into the tool diameter corresponding to the tool in the spindle. In handle jog mode, move the Z-axis in the negative direction until the end of the calibration tool is close to the table fixture. Using a flat piece of metallic material with a precisely known thickness, slide the piece of material in between the end of the calibration tool and the table fixture. The material should just barely touch the bottom of the calibration tool. Move the Z-axis in 1 micron increments until you achieve this slide fit. Press the offset key to display the work offset page. Using the part 0 set key, set G57Z. With the cursor on G57Z, subtract the length of your calibration tool from the value that's currently in the G57 work offset. After subtracting the length of the calibration tool from your G57Z work offset, we're going to subtract the precise thickness of the piece of metallic material that we slid in between the end of the calibration tool and the table fixture. Finally, we're going to save our current X and Y position using the part 0 set key. Position the cursor over the X and Y axis and press the part 0 key. At this point, we've determined all the values that we need to perform our calibration. In the program list, select the laser calibration program, then press the edit key. The program has 2 sections, a beam alignment section and a beam calibration section. We will need to move the cursor so that we are on the beam calibration section. Press the memory key and then press cycle start to start the calibration. The machine will perform a sequence of X, Y, and Z motions while performing the NC4 or NC3 calibration. Let the calibration process run through until the end. When the calibration is complete, you'll want to use the NC3 or NC4 to measure the length of your calibration tool to ensure that the calibration was completed successfully. When you measure the calibration tool, if the measured value significantly varies from the initial calibration value, you will want to run a warm-up cycle on the machine and then run the calibration again. This next section will go over calibrating the length of your touch probe. In MDI, type in G0, G90, G57, X0, Y0, and then press cycle start. This will move your probe in X and Y so that it's above the point where we established our G57 offset. Without moving X and Y, handle jog the probe in Z until it's about 5 mm above the table fixture. Under the program list, select the EasySet program. We're going to use this program to make a Z surface measurement at our current XY position. Press the Edit key and if necessary, change the S value. We want to make sure this value is not the same as a G57 offset. Press the memory key and then press cycle start. The probe is going to measure the Z surface and store a value in G58, which corresponds to the S58 that we set in our program. Press the offset key to view the value saved in G58 by the touch probe. The absolute difference between the value in G57Z and G58Z is going to be the value that we need to adjust the touch probe by. In this specific instance, the G58 value was less than the G57 value, so we will need to subtract the absolute difference from the touch probe length. We will subtract this value on the where column of our touch probe on the tool offset page. After adjusting our touch probe length, we will run the EasySet program to establish a new G58 value. If the adjustment was done correctly, the values in G57Z and G58Z should be equal to each other. If the adjustment was not done correctly, make the necessary corrections and run EasySet again until the two values in G57Z and G58Z are equal to each other.